Okay, very good morning to everyone. Fine. Before getting into today's topic, we can recap about the previous session content. So in the previous session, we have discussed about 8085 interrupt processing sequence. Okay. Can you people type it in the chat? What happened when an interrupt occurred? You consider a processor is executing a main program. Okay, it is trying to execute an instruction. Find what happens when an interrupt occurred first. Yes, kindly type it in the chat. When a processor on the main program execute at that point of time when interrupt occurred, what it has to do? Yes, it passed the main program. Okay, whether it will complete the current executing instruction or not. Yes, current instruction get executed first. Okay, after that it will acknowledge. After that it will acknowledge the interrupting device. Correct. So after acknowledging, it will push the next instruction address available in the program counter into stack. Very good, Anthony. Okay. So once it is done, next what it has to do? ஒரு interrupt acknowledge ஆயிடுச்சு அப்படினாலே it has to disable the further interrupt. Very good. Fine. ஒரு interrupt service ஆகிறதுக்கு acknowledge ஆயிடுச்சுன்னா meaning என்ன? அதோட service program execute ஆக போகுது. Fine. So at that time, automatically the CPU disable the further interrupts. Okay, except trap. Why? Except trap அப்படின்னு சொல்றோம். Why? It disable further interrupts except trap. Yes, trap is high priority. What about the other thing with trap? Is it the only reason? Yes, very good, Dixon. Non-maskable interrupt. It cannot be masked. Okay, we have seen the interrupt structure of 8085 also. Fine. Except trap. Generally, trap is used for critical error happen in the system. In the system, a critical error, most critical error, it might damage my system or collapse my program execution. This particular trap can be used to save the system. Fine. That's why it is non-maskable. Clear? Okay. So then it will go to the ISR. At the end of ISR routine, what instruction we must write so that you can enable the interrupts further and return to the main program. So we have to include EA instruction and the return instruction. Very good, Anthony Surya. Okay. When return instruction got executed, again the program control transfer to the main program. Fine. Okay. The starting address of the ISR for each interrupt can be called as what? Or interrupt order starting address. Sorry, or ISR program order starting address. Yes, very good. Vector address. If a particular interrupt occurs, it is assigned a vector address. There, the program execution get transferred automatically. Fine. So next, classification of interrupts. Fine. Among all the interrupt, which one is non-vector? Non-vector interrupt is called. Yes, INTR. Which one is non-maskable interrupt? Already you people typed in the chat. Yes? Yes, trap. Very good, very good. Okay. So the another classification is hardware, software. We know we are having 5 hardware interrupts and 8 software interrupts. Fine. Okay. Then vector address calculation of 8085 interrupt we have discussed. Okay. To calculate the vector address of any interrupt, what we have to do? How the vector address of interrupt can be calculated? Only Abhinay's typed the answer in the classroom too. What about others? Yes, 8 into the RST value, N value. Yes? Very good. Okay. Then 8085 interrupt structure part, then methods to enable or disable 8085 interrupt part. Fine? Okay. We will continue with interrupt. Okay, possibly in some 10 to 15 minutes, we will wind up interrupts of 8085. Then we will go with 8051 microcontroller. Okay, introduction to microcontrollers in the session part. Fine. So maskable interrupts and masking method part. Correct? This interrupt enable flip flop. Okay, this we can call it as global disable bit. Globally, you can disable all the interrupt except trap using this interrupt enable flip-flop. Fine. The only method to enable the INTR is what? The only method to enable the INTR interrupt is INTR interrupt enable disable எது மூலமா பண்ண முடியும்? The other interrupts are having mask bit M 7.5, 6.5, 5.5 like that. Very good. Very good, Shivakumar. Using the instruction EA. Yes, to enable the INTR interrupt, we must use the instruction EA. To disable the INTR, we must use DA. That means INTR interrupt mattum thaniya mask panna mudiyadu. When you try to mask INTR interrupt, all other interrupt also get masked. Is it clear? Okay, fine. Then we showed this slide. What are the methods to mask each interrupt? Okay, which interrupts are maskable and non-maskable? Which and all having vector address, non-vector address? Okay, then INTR. We told INTR it is non-vector. Similarly, trap is non-maskable. Fine. So there is no masking method for trap. That's why it is called as non-maskable interrupt. Fine. Then triggering method porthavaraikkum trap on the both edge and level. Whereas 7.5 on the edge sensitive, all other interrupts INTR 6.5, 5.5 are level sensitive. Fine. Okay, fine. So now we are going to discuss about SIM word format. Okay, SIM stands for what? Set interrupt mask. We have told two instructions. Okay, so that you can mask or unmask the interrupts. Okay, also you can read the status of all the interrupts. Okay, so SIM stands for what? Set interrupt mask, correct? What it means? This instruction can be used to mask the interrupts. That is the key idea of SIM instruction. Yes? Okay. So this is the word format of SIM instruction. Kindly observe carefully. Okay. Fine. What about the word size of this SIM instruction? The SIM word format, ethana bit irukku type panna mudiyuma chat la? How many bits we are having? Yes, 8 bit. Okay. Before executing the SIM instruction, this word format must be in accumulator register. Please note down. எந்த இன்டரப்ட்ல நீங்க மாஸ்க் பண்ண நினைக்கிறீங்களோ அதுக்கு உண்டான word format இதுதான். Fine. This word format can be used to apply the SIM instruction. Okay. To apply SIM instruction, the 8-bit word must be first put into the accumulator register. Okay. We can have some simple program. Okay, I will type it in the chat. Okay, once we will go through it, I will ask you to type a program. Fine. First, we will go with this bit, MSE. Kindly note down the third bit. Okay, MSE, mask set enable. That means if this bit is 0, it won't consider the next 3 bits, 2, 1, 0. You can see mask set enable means to enable the masking, you have to set this bit. That means if you set this bit MSE equal to 1, then set the mask according to bit 2, 1 and 0. Is it clear? For example, if I want to mask the interrupt M7.5, the RST 7.5 interrupt, what I have to do? 1, 1, 0, 0 I have to write. Carefully observe. Mask set enable must be 1 so that the next 3 bits 2, 1, 0 are considered. Okay, the bits 2, 1, 0 are nothing but the mask bits. We already படிச்சிருக்கோம். Mask bit 1 இருந்தா என்ன ஆகும்? Interrupt will get masked. 0 இருந்தா என்ன ஆகும்? It will get unmasked. Correct? Yes or no? Okay, fine. Then R7.5. R7.5. Okay, if you set this bit, the RST 7.5 flip-flop will get reset. In the bit நீங்க செட் பண்ணீங்கன்னா என்ன ஆகும்? RST 7.5 ஓட flip-flop இருக்குல்லையா அது reset ஆகும். Fine. Generally, RST 7.5 flip-flop hold what? The interrupt request at RST 7.5. Correct? As it is edge triggered, we had a flip-flop. The diagram path. Correct? RST 7.5 memory input. It's a flip-flop. Clear? So whenever interrupt occurred in RSC 7.5, it will get stored in this flip-flop, correct? So அந்த request நான் என்ன பண்ணலாம், clear பண்றதுக்கும் இந்த sim instruction நம்ம யூஸ் பண்ணிக்கலாம். Then this bit is don't care, it is not used. Then STE அப்படின்னா meaning என்ன அப்படின்னு பார்த்தீங்கன்னா serial data enable. Okay, to enable the serial data, this bit must be set as 1, otherwise it has to be set as 0. இங்க நீங்க serial data enable பண்றதா இருந்தால் அந்த bit இங்க தான் நம்ம வச்சிருக்கோம். A single bit, the serial output value must be present in this particular bit. Clear? So that's about the purpose of this sim word format. Okay, now I will ask you one question. Okay, now I will ask you one question. Kindly type it in the chat. What must be the sim word format to disable RST 7.5, 6.5 and 5.5 interrupt? Can you people type it in the chat? RST 7.5, 6.5, 5.5 all must be masked. Okay, at the same time you have to reset R7.5, RST 7.5 flip-flop. So what must be the word you will be writing? You don't worry about the serial output data and serial data enable bit. Okay, you just put 0 in bit position 7, 6 and 5. Okay, what about the other things? You just try it and type it in the chat. I want to mask all the interrupt as well as to reset the RSC 7.5 flip-flop. What I have to do? Which word format or which value I have to put in accumulator before executing sim instruction? Yes, any idea? Anthony Surya, I think you put 0, 0, 0. That means you are enabling all the interrupt, correct? My question is to disable all the interrupts. எல்லா இன்டரப்டையும் disable பண்ணனும் அப்படினா என்ன பண்ணணும்? See, if you put MSC equal to 0, it won't consider M7.5, 6.5 and 5.5 bit, correct? So it must be like this, 0, 0, 0, fine. Then 1, 1, 1, 1, 1, that's all. So this must be the value we have to put in accumulator. Kindly note down in the chat. To disable all the interrupt, we have to do this. Okay. What about the thing to enable all the interrupt? What about the thing to enable all the interrupt? RST 7.5 must get reset. The request stored in RST 7.5 flip-flop must get reset. That is the additional condition. Anthony Surya, I think you are trying the answer, but you are making one mistake. This bit MSC must be 1 so that the next 3 bits will be considered. Otherwise, it will ignore the 3 bits. Fine. So, what about the answer you have to write? Okay, Shivakumar typed the correct answer. Shivakumar typed the correct answer. Lokesh Nega, kindly check your answer. But what Shivakumar did is, he is outputting the logic 1. Okay, through the serial bit also. Okay, what I have told is, don't consider the serial communication now. So it might be like this, 0, 0, 0. Okay, then 1, 1, 0, 0, 0. So this is the thing what I am expecting from you people. Okay, fine. Now, find the control word to enable all interrupts of 8085. Correct? So this is the thing what I have told you. Here we didn't mention to reset RSC 7.5 flip-flop. See, you can compare SDO, SDE, then don't care. This 3 bits I have put 0, correct? Then R7.5 we are not resetting, so it is 0. Fine. We are asked to enable all interrupt. That means we have to unmask this bit so that I have to put 3 zeros. M7.5, 6.5, 5.5. Moon 0 potage. Fine. To apply this masking thing, I have to enable this bit. Mask set enable doesn't mean we are masking all the input. Fine. The 3 bits, bit 2, 1, 0, it is going to tell whether we are going to mask or unmask it. To apply this thing, we have to set MSE equal to 1. That's the meaning for it. Okay. So another thing, find the control word to reset RST 7.5 flip-flop. That is the only thing we are asking to do. So what you people have to do? Yes. Find the control word to reset RST 7.5 flip-flop. We are not speaking about any other thing. Mask பண்ணனும் வேண்டாம் அதெல்லாம் நான் சொல்லவே இல்லை. RST 7.5 flip-flop மட்டும் ரீசெட் பண்ணனும். Yes, very good Shivakumar, very good. Yes, super. See, MSE bit 0 போட்டுட்டாலே the next 3 bits become don't care. இது 1 ன்னு போட்டாதான் the next 3 bits will be considered. I think here I typed 10. I have to type 10. I made a mistake, sorry. So it is 10H. Yes, so that's all about the sim word format. Okay, can you write a program? Can you write a program to unmask all the internet? Already we have told. So this is the thing for unmask all the internet, correct? 08, correct? 08H. Can you write a program to unmask all the internet? Before executing sim instruction, what we have to do? MVI A comma, that word format has to be kept in accumulator register. Then we have to write the sim instruction, correct? So this is the thing you have to do. This is the program you have to write to enable all the input. So இது எழுதுனா மட்டும் போருமா? Whether mere writing this will enable all the interrupt? இந்த ரெண்டு லைன் எழுதுனா மட்டும் எல்லா interruptum enable ஆயிடுமா? What we have done now? No, Shivakumar, one more instruction we have to write so that the interrupt will get enabled. This ensure we are not masking the, yes, very good Anthony Surya, very good. So one more line we have to add up, correct? So we also write this instruction. So these 3 lines will do enable all the interrupts of 8085 microprocessor. Fine. We have to use EA instruction also. You just kindly refer this diagram so that you can understand what I am speaking. Fine. So idellati 000 பண்ணிட்டா unmask ஆயிடும் கிடையாது. Fine. This interrupt enable flip flop must be set. Then only the interrupt 7.5, 6.5, 5.5 and INTR will get enabled. Okay. Is it clear now? Is it clear now? Yes or no? Okay. I will ask one more question. I want to mask RST 7.5 and 5.5 interrupt alone. So what must be the thing I have to use? I wish to mask only RST 7.5 and 5.5 interrupt. You have to mask RST 7.5 and 5.5. So what is the word format, sim word format for that? Don't consider about the other thing. You are asked to mask RST 7.5 and 5.5. Anthony Surya, what you did is the reverse thing. அது ரெண்டுத்தையும் மாஸ்க் பண்ணணும்னு நான் சொல்லிட்டு இருக்கேன்ப்பா. Dixon, you also did the reverse thing. Masking means 1, unmasking is 0. நம்ம ஆப்போசிட்டா எழுதியிருக்கோம். So what will be the answer? So what will be the answer? Yes? Anthony Surya, again you are doing the mistake. What about the MSE bit? MSE bit 0 irundhuchuna, next 3 bit 101, it will not be considered. Correct? Classroom 2 la yara type pandrangala paakalam. No Shivakumar, no Shivakumar. I think still you didn't understand this concept. See, in the bit MSE kandipa enna irukanum enakku 1 irundha da adutha 3 bits consider agum sollirukkom. See, first 3 bits number 0 0 0 fill பண்ணிடலாம். Fine. Here I didn't speak about RC 7.5 flip flop. So those 0 போட்டுடலாம். Fine. 1 1 0 1. So this is the thing we have to use to mask RFC 7.5 and 5.5. Is it clear now? See, MSC bit 1 இருக்கு. அடுத்த 3 bit என்ன இருக்கு? I will put it in the second classroom also, so that you people can see what I am speaking. Is it clear now? See, 1 na you are masking the particular interrupt. 0 means you are unmasking the particular interrupt. Okay, final question, one more question. I want to mask only RST 5.5. What must be the SIM word format? RST 5.5 interrupt mattum na mask pannanum. What must be the SIM word format? Kindly try it and type it in the chat. RST 5.5 interrupt must be masked. So what I have to do? Just try it and type it in the chat. Masking means 1, unmasking means 0. Fine. To apply the masking or unmasking, MSC bit must be 1. Very good, Andy Studio. That's the correct thing. Very good, very good. Many of you are typing. Thank you. Now you people understand. I think so. So classroom tool yarume answer type pannala. So I had put in the chat. So MSC bit kandipa enna irukum namakku 1 irukanum. Fine. Then the other thing must be 001. Why 001? M 7.50, M 6.50, M 5.51. That means I'm asking only 5.5. Fine. So that's all about the SIM instruction. Next we will go with RIM instruction. Okay. So munadi nama pannadhu enadhu? Whichever interrupt we want to mask using this SIM instruction, you can apply the mask. Correct? Using RIM instruction, you can know which are all the interrupt are masked, okay, and which are all the interrupt are in pending status. What is meant by pending status? If more than one interrupt occurred at a time, what your CPU will do? First type the answer for this. If simultaneously more than one interrupt occurred, what the interrupt control of 8085 will do? Whether it will disable other interrupt? Based on priority. Very good. For example, RSC 7.5, 6.5, 5.5, INTR. அஞ்சுமே ஒரே டைம்ல வந்திருக்குன்னு வச்சுக்கலாம். Fine. RST 7.5, 6.5, 5.5, INTR. Which one will be serviced first? RST 7.5. Very good. What about the other thing? RST 7.5 தான் first நமக்கு சர்வீஸ் ஆகும்னு சொல்லிருக்கோம். But interrupt இன்னும் நமக்கு இருக்கா இல்லையான்றதை எப்படி தெரிஞ்சுக்கலாம்? By using the RIM instruction. Whether the other interrupt is requesting still or not, that we can understand. நீங்க see further other interrupts disable ஆகும்னு சொல்றோம். பட் அந்த interrupt வந்து இன்னும் ரெக்வெஸ்ட் கொடுத்துட்டே இருக்கான்றதை எப்படி தெரிஞ்சுக்கலாம்? By using the word format RIM. Fine. SIM. To write the SIM word format, which register we have used? எந்த register நம்ம யூஸ் பண்ணோம்ப்பா? Very good. Accumulator register. Similarly, read interrupt mask கொடுத்தீங்கன்னா whatever the thing status of the interrupt and its pending, everything will be read into the accumulator like this. In the word format la தான் நமக்கு என்ன ஆகும்? இந்த word format la தான் எனக்கு data கிடைக்கும். Whenever you write the RIM instruction, you will be getting a 8-bit pattern that indicate the status of the interrupt and its masking status. Correct? சரி சார், என்னென்னலாம் தெரிஞ்சுக்கலாம் அப்படின்னு பார்த்தீங்கன்னா M 7.5, 6.5, 5.5. ஸோ இந்த பிட்ல எதெல்லாம் செட் ஆயிருக்கோ அந்த இன்டரப்ட் நமக்கு என்ன மீனிங்? மாஸ்க்டு இன்டரப்ட் அப்படின்னு. ஆல்ரெடி நம்ம சிம் இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணியிருக்கோம். கரெக்டா? ஸோ அதை பேஸ் பண்ணி மாஸ்க் பிட்ஸோட வேல்யூ என்ன இருக்குன்றத RIM இன்ஸ்ட்ரக்ஷன் மூலமா we can understand. Is it clear or not? Currently, whichever interrupt are masked, that we can know at any point of time using rim instruction. Okay, what about this bit? இந்த பிட் எனக்கு 1 இருந்துச்சுன்னா மீனிங் என்ன? இன்டரப்ட் எனேபிள் ஃபிளிப் ஃப்ளாப் இப்போ 1 லாஜிக்ல இருக்கு. கிளியர்? see, முன்னாடி நம்ம பண்ணது அப்ளையிங் த மாஸ்கிங் கான்செப்ட், கரெக்ட்? now the reverse thing, whichever interrupt are masked now currently அப்படின்றது தெரிஞ்சுக்கணும்னா we simply write the instruction rim. After writing the rim instruction, you have to check each bit. So in the bit எனக்கு செட் ஆயிருந்துச்சுன்னா this M7.5 indicates RST 7.5 interrupt getting masked. இங்க நம்ம மாஸ்க் பண்றதுக்காக எழுதல, status of the mask bit we are reading. Fine. முன்னாடி நம்ம பண்ணது we are writing the mask bit, now we are reading the mask bit. Fine. So IE இந்த bit நமக்கு செட் ஆயிருந்துச்சுன்னா மீனிங் என்ன? interrupt enable flip flop set ஆயிருக்குன்னு அர்த்தம், or else all the interrupts are disabled அப்படின்றது மீனிங். Fine. Then this 3 bit P5.5, 6.5, 7.5 pending status, அதாவது இந்த interrupt வந்து நமக்கு still requestல இருக்குது, fine, பட் அது சர்வீஸ் ஆகல, that is the meaning for that. அப்படின்னா மீனிங் என்ன? ஒன்னு interrupt டிசேபிள் பண்ணிருக்கலாம், இல்ல ஒரு interrupt acknowledge ஆனதுனால remaining interrupt disable ஆயிருக்கலாம். Fine. Okay. The last thing is serial data input. Serial data input. அதாவது நீங்க சீரியல் டேட்டாவை ரீட் பண்ணிக்கலாம். SID பின்ல என்ன லாஜிக் இருக்கு அப்படின்றது இந்த பிட்ல எனக்கு கிடைச்சிரும். Fine. That's all about the rim instruction. Okay, we can have an example here also. So இத பாத்தீங்கன்னா புரியும். So M7.5, M6.5, M5.5 இந்த ஆரஞ்சு கலர் லைன்ஸ் பார்க்கலாம். rim instruction, what it will do is load the accumulator with an 8-bit pattern showing the status of each interrupt pin and mask. That's all. எந்தெந்த இன்டரப்ட்லாம் இப்போ எனக்கு பெண்டிங்ல இருக்குது, தென் அதனுடைய மாஸ்க் பிட்டோட ஸ்டேட்டஸ் ரெண்டுத்தையும் ரீட் பண்றது தான் rim instruction. Is it clearly understandable by you now? எங்க இந்த ஏரோலாம் வருது பாருங்க. M5.5 என்ன ஸ்டேட்டஸ் இருக்கோ அது இங்க வந்துடும். M6.5 என்ன லாஜிக் இருக்கோ இங்க வந்துடும். M7.5 என்ன லாஜிக் இருக்கோ அது வந்துடும். இன்டரப்ட் எனேபிள் ஃபிளிப் ஃப்ளாப் என்ன இருக்கோ அது வந்துடும். ஃபைன். தென் RST 5.5 பின் ஹைல இருக்கா, இருந்துச்சுன்னா பெண்டிங்ல இருக்குன்னு அர்த்தம். RST 6.5 பின் ஹைல இருந்துச்சுன்னா பெண்டிங்ல இருக்குன்னு அர்த்தம். RST 7.5 ஹைல இருந்துச்சுன்னா பெண்டிங்ல இருக்குன்னு அர்த்தம். If it is 0, that interrupt is not in pending status. Okay. Now coming to this. After executing rim instruction, accumulator register has 29. State the condition of the interrupt. Okay, இந்த rim instruction execute பண்ணதுக்கு அப்புறம் accumulatorல இந்த value இருக்கு. Okay, what about the status of masking of all the interrupt? எந்தெந்த interruptல இப்ப mask ஆயிருக்குன்னு சொல்ல முடியுமா? On seeing this, this is the rim word format. Okay, this is the rim word format. After executing the instruction RIM, accumulatorல எனக்கு என்ன டேட்டா இருக்கு? 29H இருக்கு. Bitwise நான் எழுதிட்டேன். Fine. Now you people can say which mark? Yes, RST 5.5 is masked. Very good. That is the first thing. Okay, RST 5.5 is masked. Then வேற என்ன சொல்லலாம்? What Anthony Surya typed is correct. RST 5.5 is masked. Yes. RST 6.5 is pending. Very good. RST 6.5 is pending. Then வேற என்ன தெரியும்? What about the status of interrupt enable flip flop? Yes. What about the status of interrupt enable flip flop? Whether all interrupts are enabled or disabled. Yes, interrupt is enabled. Fine. So RST 6.5 interrupt is pending. Interrupt enable flip flop is set now. Okay, RST 5.5 is masked. Okay, is it clear now? Is it clear now? See, rim instruction நீங்க யூஸ் பண்ண போறீங்க அப்படின்னா where you will be getting the 8-bit pattern is to the accumulator register. Similarly, sim instruction நான் எழுத போறேன்னா the 8-bit sim pattern must be present in accumulator register. Fine. This thing you have to know. This thing you have to understand. Okay. Is it clear now? Is it clear now or not? Yes, fine. Yes, fine. Okay. Fine. I hope everyone understands this concept. Okay, I will type it in the chat. One more thing, I will type it in the chat. Okay. 0, 0, 0, 1, 0, 1, 1, 0. Fine. So what about the status now? Can you people type it in the chat for this? To consider after rim instruction, this pattern is available in the accumulator register. 000101110. What about the pending status and the masked status of each interrupt? எந்த interrupt pendingல இருக்குன்னு சொல்ல முடியுமா இப்ப? Yes, RST 7.5 and 6.5 mask ஆயிருக்கு. Very good Anthony Surya. Then எந்த interrupt இப்ப pendingல இருக்குன்னு சொல்ல முடியுமா? Which interrupt is in pending now? 5.5 is pending. Okay. What about interrupt enable flip flop? What about? Yes, very good, very good. That means in the particular pattern எனக்கு accumulatorல கிடைச்சன meaning என்ன? எல்லா interruptடும் disable ஆகி தான் இருக்குது இப்போதைக்கு. கரெக்ட்டா? RST 7.5 6.5 தான் மாஸ்க் பண்ணிருக்கோம். கரெக்ட்? But apart from that, all interrupts are getting disabled except trap. That you have to understand. Okay. So இந்த மாதிரி questions தான் நீங்க expect பண்ணலாம் examல. Okay, fine. So that's all about the rim interrupt. Sorry, rim read interrupt mask. Okay, rim instruction. See, sim rim. When we have to use sim instruction, when we are in need to mask or unmask the interrupt, we can go for sim instruction. Where the sim word format must be present in accumulator register. Fine. Mere writing sim instruction will not give you guarantee that all interrupt will get enabled. Fine. You have to use EI along with sim instruction so that you can enable all the interrupt. What about rim instruction? Whenever you want to know the status of the masking and the pending status of other interrupts. Okay, except trap. Trap தவிர மத்த interruptலாம் எனக்கு mask ஆயிருக்கா இல்லையா இல்ல அது pendingல இருக்கா இல்லையா that we can know. Fine. The pending status of INTR interrupt cannot be found. Clear? Okay. So that's all about the rim instruction. So we will revise little bit, then we will move into the third module. What do you mean by an interrupt? Kindly type it in the chat. Interrupt na enapa? Who is initiating the interrupt? So now you people know what is meant by interrupt. Interrupt na enadhu? Yes. Request from IO device to get a service from CPU. That's all. Request from an external IO device or peripheral to the microprocessor to get a service. Okay. Then what are all the hardware interrupts available in 8085 microprocessor? Kindly type it in the chat. You faster type on me. Hardware interrupts of 8085 microprocessor. Yes. I'm waiting for your answer. Trap, INTR, RST 6.5, 7.5, 5.5. Very good. Okay. Generally, you have the habit of typing the interrupt in a sequence of its priority. Okay, so that you can remember. Fine. Trap, RST 7.5, 6.5, 5.5, and INTR. Which interrupt is a non-maskable interrupt available in 8085 microprocessor? Yes, very good. Trap. Very good. Very good. Which interrupt of 8085 is non-vector interrupt? INTR. Very good. Which interrupt of 8085 is edge sensitive? Only edge sensitive. Which interrupt? Which interrupt of 8085 is only edge sensitive? எந்த interrupt மட்டும் flip flop இருந்துச்சு? That's the indirect question. Which interrupt is edge sensitive? Very good. RSC 7.5. Which interrupt is both edge and level sensitive? Yes, very good. That's all. Okay. I hope everyone understand the interrupt concept very well. Okay. See, இதெல்லாம் நம்ம படிச்சா மட்டும் போதாதுப்பா. Actually, real time நம்ம லேப்ல இதெல்லாம் ஒர்க் பண்ணி பார்த்தாதான் we will be getting confidence. Okay. But unfortunately, we don't have such provisions. Fine. Okay. So now we will get into module 3. Okay. In module 3, we are going to learn what is microcontroller, an introduction to microcontroller, then architecture of Intel 8051 microcontroller, then instruction set of Intel 8051 microcontroller. Okay, then IO ports. 8051 we have 4 input output ports, so adha pathi padikka porom. Then 2 16-bit timer bar counter irukku, adha pathi padikka porom. Then serial UART of 8051, then 8051 liyum interrupt control irukku, adha pathi padikka porom. Then power saving hardware of Intel 8051, then embedded application using 8051 microcontroller. So these are the things covered in module 3. Fine. In today's class, we are going to introduce what is a microcontroller. First of all, we have to understand what is a microcontroller. I hope everyone understands microprocessor. What is microprocessor? Correct? So what is a microprocessor? What is a microprocessor? When people ask what is a microprocessor, what do you have to say? Yes, CPU on a chip. CPU on a chip. Very good. CPU on a chip. That means what are the blocks present inside the microprocessor? Enna blocks la ulla irukku padichirukkom? Functional blocks. In any microprocessor, okay, we must have ALU. Very good. ALU, timing and control unit, register. Fine. நீங்க எந்த ப்ராசஸர் போனாலும் கண்டிப்பா இந்த 3 காம்பனன்ட் இருந்தே தீரும். Fine. Okay. Fine. Okay. So now we are going to discuss about what is a microcontroller. Okay, I will show you the block of microcontroller. This is the typical block of a microcontroller. Fine. What are the things you are observing in this picture? What are the things present in a microcontroller? Yes. Can you type it in the chat? What I am displaying? Microcontroller na kandipa enna irukkum? CPU, memory, IO, peripheral devices. Okay. Adavadhu simply I can say, when I say 8085 microprocessor, to build a system, நம்ம already பார்த்தோம் இல்லையா, microcomputer trainer kit பார்த்தோம், 8085 based microcomputer trainer kit பார்த்தோம், கரெக்டா? ஸோ அந்த trainer kitல microprocessor நம்ம வச்சிருந்தோம். Then memory வெளியில இருந்துச்சா உள்ள இருந்துச்சா? I mean, whether we are having memory inside the microprocessor, 8085 microprocessor memory இருந்துச்சா? Internal? No, it have limited number of registers, that's all. Okay. Then whether internally it has port circuit internal இருந்துச்சா? கிடையாது. Fine. Can you people remember which IC I have to use to connect IO devices with 8085? ஒரு particular IC நம்ம யூஸ் பண்ணி ஆகும்னு சொன்னோம். Do you remember that? Yes or no? அந்த trainer kitல நிறைய IC நம்ம காமிச்சோம். அதுல ஒரு particular IC இருந்தாதான் என்னால input output device interface பண்ண முடியும்னு சொன்னோம். Do you people remember? Yes, I will type it in the chat. Okay. 8255. Very good, Shivakumar. I think Shivakumar typed the answer. 8255. It is termed as PPI. Okay, 8255 PPI. So PPI means Programmable Peripheral Interface IC. Okay, without this IC, you cannot connect any input-output device with your microprocessor. Okay, but all those things are present internally. So microcontroller அப்படின்னு சொன்னா என்னென்ன இருக்கு? CPU, memory, IO devices and peripherals. Correct? Peripheral devices. Fine. Can we call it as a system? Yes, can we call it as a system? Yes. So what a microcontroller can be called as? So microprocessor na CPU on a chip அப்படின்னு சொன்னோம். India we are saying system on a chip. Abhinesh, system in a board அப்படின்னு சொன்னீங்கன்னா microcomputer used, I mean microprocessor based system நீங்க என்ன சொல்லலாம்? System in a board ன்னு சொல்லலாம். Fine. இங்க system எதுல இருக்குது? Microcontroller சொன்னா. You consider this as a IC. Correct? Abhinesh, what we can call it as? அது CPU on a chip அப்படின்னு சொன்னோம். Microprocessor. இங்க சிஸ்டம்க்கு தேவையான எல்லா காம்போனன்ட்டும் சிங்கிள் ஐசில இருக்கு. So what we can call it as? SOC. Simply we can say it as SOC. System on chip. Yes, SOC. சில டெக்னிக்கல் புக்ஸ் எல்லாம் நீங்க எடுத்து படிக்கிறப்ப SOCன்னு கொடுத்திருப்பாங்க. அப்படி இல்லைன்னா MCUன்னு கொடுத்திருப்பாங்க. Fine. MCU means microcontroller unit அப்படின்றது மீன். MPU அப்படின்னா microprocessor unit. Fine. This thing and all you have to know. Clear? MPU na microprocessor unit அப்படின்னு அர்த்தம். MCU stands for microcontroller unit. SOC ன்னு சொன்னா system on chip. SOC நாலும் MCU நாலும் microcontroller ரெப்ரசன்ட் பண்ணும். MPU அப்படின்னா microprocessor unit. சில டெக்ஸ்ட் புக்ல சில அப்ளிகேஷன்ல மைக்ரோ கண்ட்ரோலரையும் என்ன சொல்லியிருப்பாங்க? ப்ராசஸர் அப்படின்னு ஜெனரிக்கா சொல்லியிருப்பாங்க. ஃபைன். பிகாஸ் ப்ராசஸர் இஸ் ஒன் ஆஃப் தி CPU is one of the block of your microcontroller. Clear? In some textbooks, even they prefer to say the microcontroller as CPU. Fine. Don't get confused. Essentially, processor controller ku enna difference அப்படினு பார்த்தோம்னா, in the case of processor, memory and interfacing circuit must be present externally. IC kulla irukad. Fine. Whereas in the case of microcontroller, definitely it should have memory and interfacing circuits and are present inside the chip. That's all. So microcontroller you can call it as system on a chip, or simply you can say SOC. Fine. Example for microcontroller based system. Okay. Can you people seen this appliance in your home? What about this? இது என்னது ஆக்சுவலா இங்க டிஸ்ப்ளே பண்ணிருக்கிறது? Yes, very good. Washing machine. Correct? Fine. Can you people try to find out the essential component present in a washing machine? Washing machine la enna nalla irukku generally? Any idea? Yes, timing unit. Very good. Timing unit. Where? Where you will give input to your washing machine. Input கொடுக்கணும் இல்லையா? நம்ம வாஷிங் மிஷினுக்கு இந்த கிளாத் நம்ம போடுறோம் கரெக்டா? ஸோ இவ்வளோ டைம் எனக்கு வாஷ் பண்ணணும். எஸ். ஸோ அதுக்கு கண்டிப்பா என்ன வேணும்? ஒன்ஸ் இப்போ வர வாஷிங் மிஷின்ல என்ன பண்ணிருக்கோம்? ரெக்டிஃபயர் சர்க்யூட். ஓகே. ரெக்டிஃபயர் சர்க்யூட். For what we need this rectifier circuit, Shivakumar? If you are using, yes, definitely it is going to use some motor, correct? BLDC motor. Okay. See, I am speaking in terms of embedded application. Okay. Yes, very good. Then LED, correct? Very good. Indication, for indication. 7 segment display. Okay, fine. Very good. Display unit where? You have to know a very important thing. Microcontroller is present in your washing machine. Correct? That's why whenever you turn on your washing machine, it is waiting for the user input. Okay. So user input கொடுக்கிறதுக்கு நமக்கு என்ன இருக்கு பாருங்க? Touchpad or touch panel. Correct? keyboard mari namak, I mean some buttons will be given. So through that you can program your washing machine. எனக்கு இந்த கிளாத் போடுறேன், இவ்வளோ டைம் எனக்கு வந்து ஹீட் ஆகணும், இவ்வளோ டெம்பரேச்சர் வாட்டர் எனக்கு வேணும், everything you can give us a input, correct? So what you are typing that can be displayed in the display unit, correct? Then it must have water level sensor, temperature sensor. Then the motor control பண்றதுக்கு we have driver. Yes, motor with driver. Then solenoid valve, water inlet outlet control பண்றது. Then buzzer, correct? Some activities happen in your washing machine can be intimated to the user through buzzer. Fine. As Dania told, LED is also present, correct? So 7-segment display அப்படின்னு போடுறீங்க, ஜென்ரலான டிஸ்பிளே யூனிட்னு போடுறது. It depends upon your washing machine. Clear? Okay. இதுல எதெல்லாம் இன்புட்னு டைப் பண்ண முடியுமா? இங்க கொடுத்திருக்கிறதுல எதெல்லாம் இன்புட்ஸ் அப்படின்னு டைப் பண்ண முடியுமா? Input devices. Input to your washing machine எதெல்லாம் டைப் பண்ண முடியுமா? Yes, very good. Keypad or touchpad. Then what about the sensors? Whether sensors are input or output device? Whether your washing machine is getting some information from the sensor or it is going to give some information to the sensor. Solenoid valve, it is output only, Abhinesh. Okay. Sensor எல்லாமே வந்து input device தான், அதுல எந்த சந்தேகமும் கிடையாது. Fine. Okay, then what about solenoid valve, buzzer, display unit and all? Driver is a output part. Okay, other things are output. Okay, so keypad, sensors, switch, இது எல்லாமே input. Okay, so these things and all output. Fine. We have a microcontroller with inbuilt memory, correct? So in the input output la connect பண்றதுக்கு நமக்கு ports இருக்க போகுது microcontroller. We no need to have 8255 here. Fine. Apart from that, to connect with computer, see the service பண்றதுக்கு, debugging பண்றதுக்கு, suppose இதில் உள்ள program change பண்றதுக்கு we need some communication. It can be either serial or wireless communication. Fine. So most of the washing machine what we have is wired communication only. See, அதில் ஏதாவது ஒரு ஃபால்ட் வந்துச்சுன்னா என்ன பண்ணுவாங்க அப்படின்னு பார்த்தீங்கன்னா, ப்ரோக்ராமில் ஏதாவது கரெக்ட் ஆயிருக்கு அப்படின்னா அந்த போர்டு நம்ம வீட்டிலேருந்து என்ன பண்ணுவாங்க, that control unit they will remove from the washing machine and they get it for service. Fine. So once அது சர்வீஸ் பண்ணதுக்கு அப்புறம் என்ன பண்ணுவாங்க, again they will fit it into the washing machine. Fine. Have you people seen that? இந்த இதெல்லாம் இருக்கு இல்லையா, டச் பேடு, இந்த இன்புட்லாம் கொடுக்குறோம் இல்லையா, அதுக்கு கீழே எனக்கு என்ன இருக்கும், எலக்ட்ரானிக் கண்ட்ரோல் யூனிட் அப்படின்னு சொல்லுவோம். ஓகே, இட் இன்க்ளூட்ஸ் மைக்ரோப்ராசர் வித் சம் PCBs. Fine. So this is one example for a microcontroller based system, correct? Microcontroller based embedded system. Fine. Then what about this thing? What about this thing? What about this thing? Is it swiper? See, இது நம்ம பார்த்தது கிடையாது எங்கேயுமே. Card swipe machine. Okay. Portable ticketing machine. Can we say like that? Busல எல்லாம் கண்டக்டர் யூஸ் பண்றாங்க, கரெக்டா? பேட்டரி ஆப்ரேட்டட் டிவைஸ், கரெக்ட்? ஸோ எந்த பிளேஸ்ல இருந்து எங்க போகணுன்றத இதுல இன்புட் கொடுத்துட்டாங்கன்னா இட் வில் ப்ரொவைட் யூ a ticket, கரெக்ட்? எஸ். ஓகே, இதுல என்னென்னலாம் இருக்கும் அப்படின்னு பாத்தீங்கன்னா, இதுலயும் கண்டிப்பா மைக்ரோ கண்ட்ரோலர் இருக்கு, கீபேட் ஃபார் ப்ரொவைடிங் த இன்புட், தென் கிராஃபிக்கல் LCD, கரெக்ட்? கிராஃபிக் LCD டு see whatever the content you are typing in the buttons. Fine. Then it should have a printer, then it might have a buzzer. டிக்கெட் நமக்கு ஜெனரேட் ஆன உடனே ஒரு பீப் சவுண்ட் கொடுக்கலாம், ஆர் எல்ஸ் நீங்க கீ பிரஸ் பண்றப்ப இட் மைட் கிவ் சம் பீப் சவுண்ட், கரெக்ட்? ஸோ இதுல எதெல்லாம் இன்புட் அப்படின்னு பாத்தீங்கன்னா, திஸ் மேட்ரிக்ஸ் கீபேட், திஸ் போர்ஷன் இஸ் இன்புட், தென் கிராஃபிக்கல் LCD யூனிட், பஸ்ஸர், டாட் மேட்ரிக்ஸ் பிரிண்டர், ஆல் தோஸ் திங்ஸ் ஆர் அவுட்புட் ஒன்லி. Fine. So here we have a power management system. As it is battery operated, you might be having a power management system. Is it clear? So this is another example for an embedded system. Fine. So what about the essential component of a system now? An embedded system now? The next semester you are going to study about embedded systems. Fine. ஒரு 5th செமஸ்டர்ல நீங்க embedded system படிக்க போறீங்க. Correct? So அதுல யூஸ் பண்ணக்கூடிய ஒரு primary component என்னது? For that purpose only we have included all these slides. Yes, very good happiness. எந்த ஒரு embedded system எடுத்துக்கிட்டாலும் கண்டிப்பா அங்க என்ன இருக்கணும்? What must be the primary thing? Yes, very good Dixon. Microcontroller. That is the primary component of any embedded application. Fine? Okay. Next. இதுல என்னென்னலாம் components இருக்கும் நீங்க நினைக்கிறீங்க? Digital thermometer. This is a digital thermometer. Fine? So இதுல என்னென்ன componentலாம் இருக்கணும் நம்ம கண்டிப்பா? Definitely microcontroller இருக்கணும். Fine? Yes. Temperature sensor. Very good. Temperature sensor. Fine. Then button must be there. So the button you press pannada adu enna pannum? It will get the reading from the sensor, okay, and display it in the display. Correct? Inge LDR theva kediyadhu Dixon. No need of LDR here. You are not sensing any light. Correct? LDR stands for light dependent system. Okay. Fine. So microcontroller இருக்கணும், push button இருக்கணும், temperature sensor, A to D converter, then graphic LCD display. Yes. See here you can see இந்த ஒரு marks வச்சிருக்காங்க. So depending upon the type of temperature sensor, anyone can be given as an input, but only one can be given at a time. Fine. So thermistor or thermocouple ஏதோ ஒரு input எடுத்து அதை amplify பண்றோம். Still it is analog signal, so it has to be converted into digital and it is given to the microcontroller unit. Correct? So the microcontroller unit enna pannum? It will display the value in the LCD. That's all. That's all about the digital thermometer. Fine. The last thing. So what about this thing? What about this system? பாத்தே சொல்லலாம், இது என்ன சிஸ்டம் சொல்ல முடியுமா? Yes, you can see this system in malls, shopping malls எல்லாம் பார்க்கலாம். Or when you go for some star hotels, you can have these things. Yes, research laboratory. Yes, door. Okay, what about this door? Automatic door. Very good. Automatic door opening or closing system. Correct? Very good. Automated door open or close system. Fine. So idhula enna components la essential ah irukku paathomna, here also we have microcontroller. Okay, we have microcontroller, then PIR sensor. Okay, PIR sensor, have you heard about this sensor? Yes or no? It's not yes, you can also use ultrasonic sensor. Okay, but PIR sensor can be used in most of this automated door open or close system. Okay, PIR stands for passive infrared ray sensor. Correct? Passive infrared sensor. We human body is going to emit some infrared radiation that can be sensed with the help of PIR. Correct? So if yaradhu human vandanga appadina enna agum, this sensor will detect, okay, and tell it to the microcontroller. So what the microcontroller will do? It will actuate the motors. That's all. Fine. The motor and continuously rotate ஆயிட்டே இருந்தா எனக்கு என்ன ஆகும்? ஒரு பொசிஷன் தாண்டி போனாலே எனக்கு என்ன ஆகும்? மோட்டாரோட மூவ்மெண்ட்ஸ் போயிட்டே தான் இருக்கும். Fine. To avoid that, what we are including here, limit switches. Fine. So PIR sensor and limit switches are input. PIR sensor என்ன கொடுக்கும்? Whether a person is there or not, it will detect that information. Fine. So once it is detected, it is told to the microcontroller. So PIR sensor will intimate the microcontroller that some person is standing in front of the door. So the microcontroller, what it has to do? It has to open the door. Correct? Fine. It will rotate the motor in one direction so that the door will get open. Fine. Once it reaches the maximum position, It can be told to the microcontroller through limit switches. Fine. Door enakku complete open aidichi close aidichi endradhu indicate pandradhukku we have some limit switches. Fine. So the switch எப்ப trigger ஆகும் அப்படினு பாத்தீங்கன்னா maximum opening or maximum closing position வந்துச்சுனா it will get trigger. Fine. So it will be told to the microcontroller so that the microcontroller will stop the door opening or closing movement. Correct. So buzzer can be used to indicate whether the system is working or not. Fine. So that's all about the door open or close system. So whatever the things we have discussed here, all are embedded system. Can you people type it in the chat? Any other embedded application you are having in your day-to-day life? Yes. Any other embedded application? Yes. Alarm. Okay. Alarm means what you are saying, Dixon. See, many gadgets and everything we are having in our day-to-day life is having an embedded system. Okay. Yes. From morning to when going for sleep, you can see variety of embedded application. Microwave oven, very good. Okay. Laptop is not an embedded system, Danya. Yes, you have to know one thing. Embedded system can do only specific task. That's all. Whereas your laptop can be used to do any purpose. Correct? So laptop and computers are for general purpose. Okay. But ஒரு billing machine வச்சிட்டு நான் என்ன பண்ண முடியும்? Bill மட்டும் தான் generate பண்ண முடியும். Yes, refrigerator. Very good, Dixon. Then air conditioner, set-top box, digital set-top box நம்ம யூஸ் பண்றோம் இல்லையா? Yes, that is having. Many other things you are having in your day-to-day life. Fine. நம்ம யூஸ் பண்ற most of the application எல்லாமே என்ன அப்படின்னு பாத்தீங்கன்னா an embedded application. Embedded அப்படின்னு சொன்னோம்னாலே for a specific application you will be having a system. That particular application will do that specific operation only. Camera, very good. Camera, it's an embedded system. Very good. Many things, okay, your data card, everything, it is having an embedded application. That's all. Fine. So now we are going to compare microprocessor with microcontroller. Okay. I will display the blocks of microprocessor here. So microprocessor அப்படின்னு சொன்னா என்னென்னலாம் இருக்கும்னு சொன்னோம். Can you people type it in the chat? ALU இருக்கு, கரெக்டா? ALU இருக்கு, registers இருக்கு. Yes, clock circuit. Here generally it is marked as clock circuit. It includes timing and control circuit. Correct. So microprocessor is going to have only register array, timing and control unit, then ALU. Correct. What about in the case of microcontroller? You can see this. Right hand side la irukkiradhu microcontroller. Left hand side la ulladhu microprocessor. Correct. So what are the things you can see here? So this portion ALU, working register, accumulator, program counter, stack pointer, clock. This entire portion you can call it as CPU core of your microcontroller. Correct? CPU core of your microcontroller. Fine. So what about the next thing? Memory, internal ROM memory, internal RAM memory. So what it means? Internal. Internal means what? You can also say it as on-chip ROM, on-chip RAM. What it means? Present inside, very good Abhinesh. Present inside. Okay. Then we have IO port, timer bar counter, serial UART, interrupt control, power saving circuit. Okay. Many other hardwares. Okay. Kanake kadayadu. நம்ம மென்ஷன் பண்ணிருக்கிறது very few hardwares which are available inside a microcontroller. இப்போ இருக்கிற மாடர்ன் மைக்ரோகண்ட்ரோலர்ஸ்லாம் உள்ள பார்த்தோம்னா you will be having some 15-17 components like this. Okay, watchdog timer nu solluvaanga, it will be present inside the microcontroller. Okay, ADC DAC, even ADC DAC it can be present inside the microcontroller. Fine. RTC can present inside the microcontroller. Many other IO components are also incorporated in the microcontroller. Okay, is it clear or not? Is it clear or not? How we are differentiating microprocessor and microcontroller? In the case of microprocessor, there won't be any memory devices inside the chip. Correct? There won't be any port or timer circuit inside the chip. Everything we have to keep it externally. Fine? Is it clear? On seeing this block, you can differentiate microprocessor and microcontroller. That's why we are having this. Is it clear to everyone? Yes or no? Are you people typing in chat? Yes, yes, fine. I think you are clear. Okay. Now we have some differences in terms of wording. Okay, left hand side I will display you, right hand side you people try to answer. Okay. One more thing, a few of the things you may not able to answer because you didn't study about a microcontroller, correct? But in general, any difference irukundadhu inga namu paakrom. So microprocessor is called as CPU on a chip. What about microcontroller? How we call a microcontroller? Yes, system on a chip. Very good. That is the first point. Then microprocessor doesn't have on-chip memory to store program and data, and additional circuits are required to interface I/O device. That means in the case of microprocessor, we don't have on-chip memory, and all other external component must be interfacing with your microprocessor need some additional circuit. Okay, external circuit இருந்தா மட்டும் தான் நம்ம என்ன பண்ண முடியும், I/O devices add பண்ண முடியும். What about in the case of microcontroller? What about in the case of microcontroller? It has on-chip memory for program and data. Fine. Then mostly all the necessary I/O or peripherals are already built into it. வெளியில நம்ம எதுவும் இன்டர்ஃபேஸ் பண்ணணும் அப்படின்ற நீடு கிடையாது. Fine. Is it clear? So நம்ம அந்த போர்டு பார்த்தோம் இல்லைங்களா, 80F ட்ரீனர் கிட், அதுல வெளியில மெமரி இருந்துச்சு, கரெக்டா? கரெக்ட், வெளியில மெமரி இருந்துச்சு. தென் போர்ட் சர்க்யூட் 8255 இருந்துச்சு. தென் டைமர் சர்க்யூட் 8251 இருந்துச்சு. சீரியல் கம்யூனிகேஷன் 8251 இருந்துச்சு. மெனி அதர் திங்ஸ் ஆர் பிரசன்ட் எக்ஸ்டர்னலி இன் தட் போர்ட். கரெக்ட், ப்ராசருக்குள்ள வேற எதுவுமே கிடையாது, எல்லாமே வெளியில தான் இருந்துச்சு. கரெக்ட். ஸோ வாட் அபவுட் த சைஸ் ஆஃப் த போர்ட்? ஒரு கண்ட்ரோலர் நான் யூஸ் பண்ற இடத்துல, I mean ஒரு ப்ராசர் நான் யூஸ் பண்ண அந்த ஸ்பேஸ்ல, when I'm having a controller, it is everything is available in a single chip. Correct? So microprocessor are used as CPU in general purpose computer. What about microcontroller? General purpose applications ku na microprocessor use பண்ணலாம். What about microcontroller? Just now I have told you. General purpose computing அப்படின்னு சொன்னோம்னா we have to go with microprocessor only. What about in the case of microcontroller? For embedded application, very good. So microcontrollers are used in control oriented specific application. ஏதோ ஒரு parameter நான் ரீட் பண்ணி ஒரு விஷயத்தை நான் கண்ட்ரோல் பண்ண போறேன் அப்படின்னா, that your microcontroller best suit rather than your microprocessor. Okay, after we go with all these differences, you can understand why microcontroller is preferred in embedded application. Okay, then extensive instructions. Okay, அப்படின்னா மீனிங் என்ன அப்படின்னு பாத்தீங்கன்னா, இங்க நம்ம யூஸ் பண்ற இன்ஸ்ட்ரக்ஷன்ஸ் எல்லாமே very complex operation it is going to do. Fine. So that the performance of computing can be improved. What about in the case of microcontroller is reduced instruction set. சிம்பிளா சொல்லணும்னா மைக்ரோப்ராசஸர்ல ஒரு இன்ஸ்ட்ரக்ஷன் பெர்ஃபார்ம் பண்ணக்கூடிய ஆபரேஷன்ஸை கட் டவுன் பண்ணி ஸ்டெப் பை ஸ்டெப்பா ரெடியூஸ் பண்ணி single instruction or simple instructions will be there, so that it can be executed by the microcontroller in a faster way. That's it. Is it clear for you? Extensive instruction set அப்படின்னா மீனிங் என்னன்னா, ஃபார் எக்ஸாம்பிள் இப்படி சொல்லலாம், மெமரில இருந்து ஒரு டேட்டாவை எடுத்து அக்குமுலேட்டர் கூட ஆட் பண்ணி எனக்கு வந்து மெமரியிலே போய் ஸ்டோர் பண்ணணும் அப்படின்னா, ஸோ அதுக்கு எல்லாமும் மைக்ரோ ப்ராசஸர்ல we have instructions. Whereas in the case of microcontroller, we have to get the data from memory, then you have to perform addition, then you have to transfer it to the memory. So in that way you can do it. Fine. அதாவது the nature of the operation of the instructions are very simple in the case of microcontroller, whereas in the case of microprocessor it is very extensive. Okay, then many instructions are available to handle data from external memory. And microprocessor பொறுத்த வரைக்கும், as it doesn't have on chip memory, most of the time it is going to access the memory. Okay, program எடுக்கிறது fine, அதை decode பண்றதுக்கு எல்லாமே மெமரியில இருந்து தான் எடுக்கணும். Correct? To execute any program, the microprocessor frequently access the memory externally present in the IC. Correct? In the system. Is it clear? Many instructions in microprocessor handle data from external memory. What about in the case of microcontroller? May have one or two instructions to handle data from external memory. Fine. What is the purpose of going for microcontroller for embedded application? See, எனக்கு மெமரி எல்லாம் ஆன் சிப் இருந்தா எனக்கு மெமரிக்கு உண்டான ஸ்பேஸ், அடிஷனல் ஹார்ட்வேர் எல்லாத்தையும் நான் வந்து ரெடியூஸ் பண்ணிக்கலாம். அந்த பர்பஸ்க்கு தான் நான் மைக்ரோ கண்ட்ரோலர் போறேன். கரெக்ட்? That means it no need to read the code from external memory. Fine. Code எல்லாமே நமக்கு ஆன் சிப் மெமரியில இருக்க போகுது. Fine. So it doesn't need this thing. That means it doesn't need to read the external memory frequently to do any operation. But when your application size increases, என்னோட embedded application ஓட size increase ஆகிறப்ப program memoryக்கு எனக்கு இடம் பத்தாம போலாம், இல்ல data memoryக்கு இடம் பத்தாம போலாம். In that case, you can have the optional external memory also. நல்லா புரிஞ்சுக்கணும், மைக்ரோ கண்ட்ரோலர்ல உள்ள மெமரி எனக்கு பத்தல என்னோட அப்ளிகேஷன்ல அப்படின்னா, at that point of time you can go for some external memory. Fine. So on the timeல you can have the provision of accessing the external memory. Fine. It should have only one or two instructions to access the external memory. That's all. Then most of the instructions perform byte operation and have only less number of bit operation instruction. You can compare 8085 microprocessor bit operation instruction அப்படினு பார்த்தோம்னா a very few instruction we can have. Okay, STC அப்படினா மீனிங் என்ன? 8085 ல STC னா மீனிங் என்னப்பா? The instruction STC, what it will do? Yes, STC instruction என்ன பண்ணும்பா 8085 ல? மறந்துட்டோமோ? Yes, set carry bit. So it's a bit operation. Any other bit operation you can have in 8085 microprocessor? Any other instruction? CMA means 8-bit byte operation only. Correct? Complement accumulator means it's a byte operation. Bit operation. I am speaking about bit operation. CMA க்கு பதிலா CMC சொல்லலாமா? Yes. Very good, Logus Nega. CMC. Very few number of bit instruction we are having in microprocessor. Okay, whereas microcontroller definitely need a good bit operation instruction so that it is best suited for a control application. See, ஒரு control application அப்படின்னு போறப்ப ஒரு போர்ட்ல 8 பின் இருக்கும். அந்த ஒவ்வொரு பின்னும் இண்டிபெண்டன்ட்டா நான் ப்ரோக்ராம் பண்ணோம் அப்படின்னா we need more number of bit instructions. Okay, many bit operation instructions are available which best suit for control application. For example, நான் ஒரு 7 சென்சார் கனெக்ட் பண்ணியிருக்கேன். ஃபைன், 7 சென்சார் நான் கனெக்ட் பண்ணியிருக்கேன் ஒரு போர்ட்ல. ஃபைன், ஒரு பர்டிகுலர் சென்சாரோட ரீடிங் எனக்கு வேணும் அப்படின்னா அந்த பர்டிகுலர் பிட்டை மட்டும் நான் ரீட் பண்ணா போதும், whether it is 1 or 0. Is it clear? See, this kind of things you can understand when you do projects. Okay, see, bit instruction is very, very important in the case of microcontroller. Okay, that only best suit for control application. Okay, then addressing range is higher. Generally, your laptop and PC, personal computers, are meant for general application. You can do any application with your computer or laptop. Fine. For example, நான் ஒரு ticket vending machine ஆவும் நான் யூஸ் பண்ணிக்க முடியும். Just என்ன பண்ணலாம்? Just by connecting a printer and installing some software in your computer, you can use your computer as a billing machine. Fine. You can use it as a weather station. Fine. A vast kind of application you are running in your computer. That's why you require more memory space. நீங்க உங்களோட லேப்டாப் ஆர் கம்ப்யூட்டர்ல ஹார்ட் டிஸ்க் கனெக்ட் பண்ணிருக்கீங்க, அதோட சைஸ் என்ன ரேஞ்சில் இருக்கும்? மெமரி சைஸ் எவ்வளவு இருக்கும்? What about the size of your hard disk or any other thing? Yes, it is in terms of terabyte, correct? What about the size of RAM you are using in your computer? 4 GB or 8 GB, 2 GB, it's in that order, fine? So it requires a higher addressing range. Whereas in the case of washing machine or vending machine or some other thing, you need a specific operation to be done. Correct? So adukku namakku nariya memory space venuma? தேவைப்படாது. Fine. Relatively you are having a smaller addressing range. அதாவது மைக்ரோ கண்ட்ரோலர்ல நீங்க போறப்ப அதோட ஆன் சிப் மெமரி பாத்தீங்கன்னா வெரி லிமிட்டட் தான். Fine. 4 KB, 8 KB, 16 KB or in terms of KB or MB தான் இருக்கும். Whereas microprocessor application அப்படின்னு போறப்ப you are having a very good addressing range so that it can run many programs simultaneously from different addresses. Clear? Okay. So higher processing speed suitable for faster computation. See, என்னோட லேப்டாப் ஆர் கம்ப்யூட்டர் அப்படின்னு போறப்ப higher computation that is very very essential for a laptop or computer. Fine. So எல்லா லேப்டாப் கம்ப்யூட்டர்லயும் கண்டிப்பா மைக்ரோ ப்ராசஸர் தான் நம்ம யூஸ் பண்ணுவோம். கரெக்ட்? Yes. What about in the case of microcontroller? Microcontrollerல you will be having some sensor. Fine. And actuators, motor and the device use பண்றோம். That and all slow peripheral device. So faster speed அப்படின்றது இங்க அதிகமா தேவைப்படாது. Fine. Relatively microcontrollers are operating at slower speed when compared to microprocessor. It doesn't mean microcontroller எல்லாம் ரொம்ப ஸ்லோவா தான் ஒர்க் ஆகும். It is not like that. Please don't think like that. Microcontroller is also operating at a higher speed, but when compared to microprocessor based system, it is operating at slower speed. Microprocessor oda compare பண்றப்ப microcontroller are operating at slower rate. Fine. Then cost of the microprocessor based system is generally expensive. Fine. Why it is? Because in the case of microcontroller, you are having everything inbuilt into the chip, but it is limited resource. You don't forget that memory nariyalam kediyadhu. Fine, but it best suit for an embedded application. Fine. Whereas in the case of microprocessor, you have to put everything external to the IC. IC க்கு வெளியில தான் எல்லாமே இருக்கு. Fine. So உங்களோட CPU cabin எடுத்துக்கோங்க, அது எவ்வளவு பெருசு இருக்கு. Fine. It requires many components to be present externally. Fine. So அதுக்கு interfacing hardware, so அந்த each and every component ஓட cost எல்லாமே கம்பேர் பண்றப்ப cost of the microprocessor based system வந்து expensive ஆ தான் இருக்கும். Relatively microcontroller based system are less expensive. Okay, there is a difference between the microprocessor and microcontroller based system. Okay, in terms of cost. Then hardware complexity obviously microprocessor la jaasti, microcontroller la kam. Fine. By conclusion, we can say microcontroller can be used for specific application. For that purpose only microcontrollers evolved. Fine. Simple ஒரே ஒரு क्वेश्चन கேட்கலாமா? ஒரே ஒரு LED நான் blink பண்ண வைக்கிறேன். Fine. ஒரு LED நான் blink பண்ண வைக்கிறேன். Fine. So இதுக்கு நான் மைக்ரோ ப்ராசஸர் ப்ரிஃபர் பண்ணுவோம், மைக்ரோ கண்ட்ரோலர் ப்ரிஃபர் பண்ணுவோம். I want to control a single LED blinking. Whether we need to go for a microprocessor or microcontroller. You give justification. Which one best suit? Whether microprocessor will best suit? Yes, microcontroller. Dixon, very good. Shivakumar told microprocessor. Or LED blinking na microprocessor use panna appadina. Okay, let's compare. Fine. First of all, even though I say LED blinking அப்படின்னு சொன்னாலும், we need to write some program. Where the program will be stored, Shivakumar? அந்த program எங்க ஸ்டோர் பண்ண போறோம் நம்ம? Memory, correct? So memory வந்து ப்ராசஸர்ல இருக்கா நமக்கு inbuilt-ஆ? Whether we are having an inbuilt memory? No, definitely no. So additionally, memory device வேணும். Memory device இருந்தா போதுமா? கிடையாது. We need some connection between the memory device and your microprocessor. Correct? So hardware complexity ಜಾಸ್ತಿ ಆಗಿದೆ. First thing. Whether we have port pin in microprocessor? No. We have to externally add up some port devices. Correct? So even to connect a single LED and program it, we need many external resources in the case of microprocessor. Fine? Sharing sir, or LED blinking na pananumna, adukku ethana line code eludha porom. LED on, delay, LED off, delay. That's all. இவ்வளவு தான் நம்ம எழுத போறோம். கரெக்ட்? இதுக்காக ஒரு மெமரியை போய் நான் எக்ஸ்டர்னலா கனெக்ட் பண்ண முடியுமா? Fine? See, if you implement a LED blinking system with a processor, size of the system become larger, hardware complexity will be more, cost will be more. Fine? Many other things. Okay, not only this thing, in many aspects, microprocessor cannot be preferred for this. Okay, whereas microcontroller means just ஒரு crystal connect பண்ணா போறோம், power supply கொடுத்தா போதும். Port pin ready-made available. Straight away you can connect your LED. Less hardware circuit, less external component are required in the case of microcontroller based system. But microcontroller system cannot best suit for higher computation application. Say for example, camera சொன்னீங்க இல்லையா? When you are going for camera, even though it is an embedded application, there they use special microprocessor system. Okay, microprocessor, microcontroller illama special microprocessors are available, special purpose microprocessor that mainly meant for capturing image and compressing it and storing it into the memory. Fine? Special purpose computing adukku thaniya irukku. Fine? Is it clear for everyone? Yes. Let me revise little bit. What are the essential blocks of a microcontroller? Can you type it in the chat? What are the essential blocks of a microcontroller? CPU, memory, peripheral, I/O. Very good. CPU, ROM, RAM in terms of memory and I/O device. Everything are inside the microcontroller. Fine. Is a microprocessor best suited for building a washing machine system? Microprocessor suit ஆகுமா washing machine build பண்றதுக்கு? Definitely no. Why? See, in the case of washing machine, user தேர்ந்து சில inputs read பண்ண போகுது. கரெக்டா? சென்சார்ல இருந்து data read பண்ண போகுது. Fine. Then we need a small coding to control your washing machine. Fine. This kind of application doesn't require a larger memory space or it doesn't require a faster computation. எனக்கு பொறுமையா வேலை செஞ்சா போற washing machine. Fine. Computation எனக்கு ஸ்லோவா நடந்தா போதும். See, wherever system it involve any real-time machineries or hardware, they are slow only. Even printer எடுத்துக்கோங்க. நீங்க print கொடுத்த உடனே ஒரு flashல print ஆகுமா? கண்டிப்பா கிடையாது. Printer, it's an embedded system. Whether it uses microprocessor or microcontroller. நம்ம யூஸ் பண்றோம் இல்லையா printer, laser printer. It is microcontroller based system only. Fine, it's an embedded system. Okay, so definitely no, microcontroller can be preferred. Microprocessor use பண்ண முடியாதுன்னு கிடையாது. Please understand the word. Microprocessor can also be used in a washing machine system, but it doesn't best suit. Optimala irukadu. Fine. Which can be preferred in generic or general purpose application, microprocessor or microcontroller. எனக்கு நிறைய அப்ளிகேஷன்ஸ் நான் ரன் பண்ணணும் என்னோட சிஸ்டம் அப்படின்னா என்ன பண்ணணும்? Whether I have to go for microprocessor or microcontroller. Microprocessor can be preferred for generic application. Generic அப்படின்னா general purpose. எது வேணும்னா பண்ணலாம். Whatever you can do by adding some external devices with your processor. Fine. So microprocessor can be preferred for general purpose application. Is on-chip memory available in microcontrollers? Yes or no? Microcontrollers la on chip memory irukuma? Definitely yes. Definitely yes. But 8031, kindly note down, 8031 is the only microcontroller. Okay, 8031 is a microcontroller. It doesn't have ROM. ROM-less microcontroller அப்படின்னு சொல்லுவாங்க. மெமரி கிடையாது அந்த மைக்ரோகண்ட்ரோலருக்கு மட்டும். பட் ஜென்ரலா மைக்ரோகண்ட்ரோலர் சொன்னா டெஃபினட்டா மெமரி இருக்கும். Fine. How the input output device are connected to microcontroller? மைக்ரோப்ராசர் கூட கனெக்ட் பண்ணோம்னா எக்ஸ்டர்னலா 4 சர்க்யூட் 8255 வேணும்னு சொன்னோம். Where you can connect with microcontroller. Directly you can interface to the ports of microcontroller. Correct? Port pin. Very good. I/O devices can be connected through I/O port pins. Correct? I/O port pins. So that's all about the introduction to microcontroller. Fine. So the next class, the very next class, the next session, we will be going to discuss about the 8051 microcontroller, Intel 8051 microcontroller. So that is the thing we are going to see in module 3. Fine. Each and every corner of 8051 microcontroller we are going to learn. So next session let the continuous class attend பண்ணீங்கன்னா you will be having a good knowledge on 8051 microcontroller and you can do any project using 8051 microcontroller. Fine. So இது வரைக்கும் நம்ம பேசினதெல்லாம் தியரிட்டிக்கலா பார்த்தோம். Fine. So microcontroller it's really an interesting concept. Okay, many things we are going to learn in the microcontroller. Fine. 8051 microcontroller. Okay, so அடுத்த செஷன்ல இருந்து கொஞ்சம் நல்லா இன்டராக்டிவா கவனிங்க. ஒரு செஷன் கூட மிஸ் பண்ணிடாதீங்க microcontroller session. Fine, so that you can do a good project. Okay, so here I can stop. Here I am going to stop.